Welcome to this new tutorial for the coupling of SimulationX with Python. In the last video, we discussed the principal structure of the COM interface, how you access first the application and then the document. And in this session, we want to start a simulation using a script and also modify some parameters. Okay, so let's start. I want to start with a sample. You see it already here. So you go to samples, and I want to use the centrifugal. So you just need to type a part of it. Center is already sufficient. Centrifugal elastically mounted. Open in SimulationX. So that we start from something. So we do not discuss building the model today using scripts. We just assume we have a already built model, and we will automate the simulation. First step is that we create a new Jupyter notebook. So right-click the tab, and from the context menu that pops up, open Jupyter notebook. So then we have it. We will not use the SimulationX tools for now. We will simply delete the content of the cell and just start with what we discussed last time. We import win32com.client. I run this cell with Shift-Enter so that I get a new one. And then I get a pointer to SimulationX. You should always use the tab key to avoid a lot of typing. And we use the dispatch method to connect to esi.simulationx47. And additionally also get immediately, or maybe do that this, and then we say doc equal to sim. You just need to type A and you get active document, so that we have a pointer to our active document. So, and then you can already use again the tab key. And with the tab key, that's actually an easy method in Python or in Jupyter actually, or also IPython, to get available methods or properties. So you see the methods with an F for function, and the properties have this I here. You can scroll through it. You can begin to type if you have a clue what you will do. And let's change the simulation time first. So the stop time would be 10 seconds currently, and we want to change the stop time to 10 seconds. We just do this by the lookup method and ask for the parameter. This is actually a parameter which is directly associated to the model. So if you double click the model, here in the structure view, you see here t-stop, which is a parameter directly of the model. So the relative ident with respect to the model is this. And then we assign it a new value, let's say 15 seconds. And it's SI, or it's actually the unit that is selected in this dialog, and this is typically seconds, at least for this model. So now, actually, it should be already updated. The view is not updated yet. Let's use a doc update method. So now with doc update, also the view is updated. The value would be there inside already. And now we could even already say doc start. And doc start, so again, tab, right? Tab start. Oh, sorry, start, tab key. And yeah, you have a possible input argument for the mode, but 0 is the default, and default is transient simulation, and this model is only, in this case, we just want to use the transient simulation. So, and with doc start, there you see global symbolic analysis already running, simulation runs, we're done. And after that, we could already plot some results. So we can use doc.result windows And there's a method which is add YT. And with add YT, you see the signature here with for the auto completion here for the signatures. That's a Jupyter method actually. It's not dedicated to SimulationX in this case, but it lists also the methods of the COM interface. And we insert here a result name as the first parameter. Okay, and that would be sufficient for this call. And I want to see the relative speed of the Revolut joint. It has a result quantity which is called omrel. So I would need to formulate the ident Revolut joint dot omrel. There's a shortcut to do this. I select this here in the property dialog, select this small button down, and copy the full ident. And with that, I simply need to paste it here. Full ident in this case means full ident with respect to the model. And if I do that, you see, I get a result window. And it even has a return value, which I currently do not use. So you would get some result window. And if you call this command again, of course, you get an additional result window. And I also want to show what happens if we have a 3D quantity. So like here in the free motion, you have a quantity xrel. Also copy that full ident. Sorry, here. Then you get a result window with the whole vector inside. So for X, Y, and Z. Colors may be different in your case. That depends on your configuration, how you set up the default look of your result windows. Okay, so that's the basic already. So now, what about running an additional simulation? Before we can do that, we need to reset the document. That would be doc.reset. Right, so now it's reset. And we could start the simulation again. Could do that here with simply evaluating this cell one more time. With, I think it's Control Enter if I do not want to add a new one. So you see, simulation is started again. Yes. What about if the simulation would fail? So we need to, if we want to build a loop for an optimization, which is actually what we want to do next time, there is the question about the solution state of the model, and there is a property which is called solution state, and this is currently 16, and 16 means it's successful. If I reset the model, the solution state is 2, which means it's ready to simulate. And actually, to get a failed state, yeah, let's provoke this even. So just inserting some invalid expression. I think that's a new feature. Need to get an invalid expression. So I can here say I want to reference function 1.f, so function 2.f actually. And then I rename this function into function 3 so that I get an invalid reference. So if I press doc start now, I get an error and I have a solution state 32, which is error. And of course, I should check this when I run a simulation. And for longer simulations, also wait for the simulation to be done. Because if we look carefully, if we reset that model one more time, let's even remove this error stuff here. Reset the model. Run it one more time. If you look carefully, the cell is already evaluated, so you could already run the next command before the simulation even has finished. And this is why it's reasonable to put some loop which waits for the simulation to be finished. And typically we do that with a while doc.solution state is actually it's should be running. And yeah, where do we find this information without needing to test this? Actually, it's pretty simple. We use the documentation, and there we look for solution state. We get this actually as the first hit. So there is a sim solution states enumeration, and you see running is 8. And we could check for while the simulation is neither stopped nor failed, or we could also check for running. But it's simpler to wait for either sim running or sim stopped. Not in 8 or 16. We need to import time for that. And we say, of course, we start the simulation before. Then we say time.sleep. Time.sleep takes an argument in seconds. So let's wait for 100 milliseconds. Yeah, and then we print doc.solution state. So, and it's always a good idea to put a reset even before the start. It doesn't matter if the model is already reset. Sorry, 8 is running. 32 is failed, right? So 8 was running, so this is why it returned immediately. 16 or 32. So now one more time. You see cell is still evaluating with this small asterisk inside the input cell number. And after that, the simulation is then done. Okay, so that should be all for the simulation. As I mentioned in the next videos, I think we will take it will take a bit more than just one video. We will try to put a small optimization loop around such simulations. And yeah, but for now, for the simulation itself, I think this is all. Maybe one more comment to the simulation loop here. This is very simple, and it's already in the there is a sample model or a sample Python script inside the samples collections of SimulationX. So if we go to this model and say save as, you find the path where all these samples are located. Within samples, you find a scripting folder, which is here. And if we search for, if you take this, use an explorer and navigate there. So that's here. There are sample scripts. One is also even a Python file. And here you will see also this part, maybe a bit different, but similar. Adding some. So this is a further point of reference if you are interested and do not want to wait for all the next videos. There are also Visual Basic Scripts videos inside. And actually, the syntax would be in some parts, at least with respect to the COM interface, it would be very similar to what we do with Python if we use the direct access to the COM interface. Yeah, last not but least, maybe one more point. We deleted that cell in the beginning. So I do this now for an empty model here. I create another Jupyter notebook, which is now for this empty model, which I can also simulate. And this is what I want to show. There is, of course, a method within our PyTools package, which runs a model and already has some parameters like the document you want to run, which would be the default. The default is the current model that you are having. The sleep time, really you need the start, stop time, and also some progress. So you can also simply use this method. And it will also run the model, which is quite quick, of course, for this empty model. Okay, so now we are done. Thanks for watching and see you next time.